Hello guys, have a cooked soup or boiled vegetables and added salt to make them taste better. What happens when you add salt to water and stir it? Let's take a teaspoon of table salt, pour it into the glass of water, stir and see. It looks like the salt disappears into the water. However, as the law of conservation of mass says, in a closed or isolated system, matter cannot be created or destroyed. It can change forms but is conserved. Salt is still present in this glass of water, but it has changed its form. It is not solid anymore, but what we have here is an aqueous solution. The table salt we've just used is known in chemistry as sodium chloride. Sodium chloride is an ionic compound with a chemical formula NaCl, representing a 1:1 ratio of sodium and chloride ions. Sodium is in the first column of the periodic table, so the sodium atom in this compound loses an electron to become Na+, while chlorine is in the second to last column, so the chlorine atom gains an electron to become Cl-. Each atom in this ionic compound will lose or gain one electron, so they can pair in a 1:1 ratio. Together, they form a neutral compound because the ions balance each other out. This is true for all ionic compounds. The positive and negative charges must be balanced. When ionic compounds dissolve, the resulting solution contains the separated ions. Can the separated ions pack back together in an aqueous solution? No, they cannot. My blender model will explain. When the solid dissolves, the ions are separated and dispersed throughout the solution. The strong ionic forces that hold the sodium chloride crystal together are overcome by the strong attractions between the ions and the polar water molecules. Each polar water molecule orients itself in a way to minimize its attraction with a chloride or sodium ion. The negative oxygen end of a water molecule is attracted to a positively charged sodium ion, while the positive hydrogen end is attracted to a negatively charged chloride ion. The strong forces holding the positive and negative ions in the solid are replaced by strong water-ion interactions, and the solid dissolves, the ions disperse. Thus, when salt, an ionic compound, dissolves in water, it breaks up into individual cations, positive ions, and anions, negative ions, which are dispersed in water. Surrounded by water, ions are separated, the salt crystal is broken and cannot reform. In virtually every case, when a solid containing ions dissolves in water, the ions separate and move around independently. That is, in this glass, sodium chloride solution does not contain NaCl units. It contains separated Na+ and Cl- ions. In the solution there is one Na+ ion for every Cl- ion. Chemists know that separated ions are present in this solution because it is an excellent conductor of electricity. Pure water does not conduct an electric current. Ions must be present in water for a current to flow. Let's use this conductivity indicator to measure the conductivity of pure water. The result is 0, meaning that pure water does not conduct electric current. Now let's use the same device to measure the conductivity of our sodium chloride solution. The result is 4, meaning that sodium chloride solution does conduct electric current. What if we decide to use the conductivity indicator to measure the conductivity of sodium chloride solid? The result is 0, meaning that salt does not conduct electricity on its own. As an ionic compound, when dissolved in water, Sodium chloride breaks into ions that move and conduct electric current. When each unit of a substance that dissolves in water produces separated ions, the substance is called a strong electrolyte. Sodium chloride is a strong electrolyte in water because each NaCl unit produces the separated ions Na+, Cl-. That is, Na+ cations and Cl- anions, which move around independently, and that is how the electric current is conducted. Thank you for watching my video. I hope you enjoyed it and find it useful.